In this video, I'm going to take you all the way through all the algebra questions up to passing at GCSE grade. So first of all, we need to simplify these expressions. So I'm going to add these c's together. There are 4 c's there. Here, I'm going to times these p's together, and there are 4 of those, so that's p to the power of 4. Now, a lot of people get these two types mixed up. When you're timesing, we need a power there. 3g plus 5g, that's 8g. 2r times 5p, that's 10rp. And then simplifying this expression here, I've got 5p. Later on, I'm taking away 3p. So in all, that leaves me with 2p there. Now let's go on to the q's. 2q, take away 3q, that's minus 1q. A little bit of substitution. So I've got this expression here, and I need to substitute in these values. So I'm going to rewrite the expression again, but substituting what I know the letters actually are. So it's 3 lots of 5 plus 4 lots of minus 2. So 3 times 5 is 15. 4 times minus 2, that's minus 8. So now I've got 15, take away 8, and that is 7. Okay, given that y equals 4x minus 3, work out the value of x when y equals 11. So I'm going to rewrite this equation again, but I'm going to write 11 there instead for y. I'll write 4x minus 3. So now it's minus 3 here. I'm going to move it over and add it to the other side. Equals 4x. And then I'm going to divide by 4. So 14 divided by 4 is 3.5. Okay, moving on to sequences now. Here are the first 5 terms of a number sequence: 3, 8, 13, 18. Write down the next 2 terms of the sequence. Well, I can see that it's going up in 5, so I'm going to add 5 there, and then I'm going to add another 5. Explain how you found your answer. Well, it's only worth 1 mark. I don't want to go to town on this. It is early on in the exam paper, and there it is. I added 5 each time. That's all I need to write there. Okay. Next section, explain why 387 is not a term of the sequence. Again, nothing too difficult there because it would be early on. So here we go. All numbers in the sequence end in 3 or 8. Okay. However, I must put this bit in. However, 387 ends in a 7. Okay, now looking at nth term of a sequence. Now we have a sequence, work out the 8th term of the sequence. Well, it's going up in 4s each time. I've got 3 more steps to get to the 8th term. So I've got 3 more steps of 4, which is 12. So I'm going to add that to the 19, which is 31. There's lots of other ways you could get that as well. Write down the expression in terms of n for the nth term of the number sequence. Well, it's going up in 4s, as I said, so it's going to start out as 4n. If it was 4n alone, however, the first term would have been a 4. It's not, it's a 3, so I've got to take away 1. And incidentally, this will help me get the 8th term as well here. 4 times 8 is 32, take away 1 is 31. First 5 terms of an arithmetic sequence are this: find terms of n, an expression for the nth term sequence. Well, it's going up in 7, so again, it's going to start out as 7n. If it was 7n alone, the first term would be a 7. It's not, it's a 2, so I'm going to take away 5. So it's 7n minus 5. Equations now. Here we go. So I've got 2t. I am going to take away 8 from the other side because that was adding 8. I take it away, so I'm now going to have minus 5. I'm now going to divide by the 2, so minus 5 divided by 2. The answer here is minus 2.5. And then here, I've got to leave the y on its own, so I want to move the 5 over first. So I've got 2y equals, well, the 5 was dividing. If I move it over, it will do its opposite job, which is timesing. So 4 times 5 is 20. And now I'm going to divide by the 2. So divide by 2, 20 divided by 2 is 10. There we go, so y equals 10 there. Now, slightly harder equations here, and you can see I've got the x on both sides of the equation here, which is a little bit of a problem. What I'm going to do is I'm going to eliminate it from one side. Looking for the smallest of the x's, which is over here, 11x. I'm going to take, what I'm going to do is going to start by taking away 11x from both sides. Here we go. So if I take it away from the left-hand side, I've got 2x plus the 1 still. And then on the right hand side, take it away, I'm just now left with 9. So here I've got a much more simple equation. 2x equals, well, I'm going to take away the 1 now, so I'm left with 8. And then, of course, x equals 8 divided by the 2, so here x equals 4. Very similar down here, looking for the smallest number of t's. Well, that was 3t, so I'm going to take away 3t from both sides. On the left, I'm left with 2t minus 4. On the right, I'm just left with 6, so no more t's. So if I move the 4 across, it was taken away. It will now be adding, so I've got 2t equals 10. So that means that t must equal 5. Okay. Looking at forming an equation now and then solving it. So in this quadrilateral, the size of the angles and degrees are as given here. Use this information to write down an equation in terms of x. Now I need to think about what I know about a quadrilateral. We're dealing with the angles here, and I know that angles in a quadrilateral add up to 360. So what I'm going to do is I'm going to add these up. So my total number of x's is 5. X plus another 2x plus another 2x. That is 5x. And if I add the numbers together here, that's 60. And I know that that equals 360 for the total number of degrees in a quadrilateral. So there I've done, I've got an equation now in terms of x. Work out the value of x, so I've just got to solve this equation now. So 5x equals, now 360, take away the 60, that's 300. And now I need to do 300 divided by 5, which is 60. There we go. Expanding now. So it says here expand and simplify. So I'm going to expand each of these brackets. 3a times, sorry, I apologize. 3 times 2a is 6a. 3 times 5 is 15. Now moving over here, 5 times a is 5a. And that 5 times the minus 2 is minus 10. So that's for 1 mark there for my expansion. Now I need to simplify. 6a plus 5a, well, that is 11a. And then I've got 15 minus the 10, that is going to be just 5. Okay, quick expansion here. 3 times 2y, that's 6y. 3 times minus 5, that is minus 15. So expansion there, expanding. Right, slightly harder now here. We've got the equations and expanding here. So if you ever see an equation with some brackets in, my suggestion is to expand them first. So 5 times t is 5t. 5 times 3 is minus 15. So all I've done is simply expand the left-hand side first. So 5t now then equals, well, I'm going to add the 15. So 5t equals 40. And now I'm going to divide the 40 by the 5. So that leaves me with t equals 8. And I would do the same here. I would expand this to get myself a regular looking equation and then solve it. Factorizing now, that's the opposite of expanding. If you remember, we'll just look at the expansion here first. X times x is x squared. X times 2 is 2x. So factorizing is the opposite. What I need to do now is take out the common factors here. Common factors in this expression are x. Okay. Then I need my brackets open here. Now, what would I have here? That when I times it by x would give me x squared. Well, that's going to be x. And then what would I have here? That when I times it by x would give me 7x. Well, that is just 7. And a plus sign in the middle there because that's plus 7x there. Slightly harder one here. Factorize completely. Take out as many common factors as I can. If I look at the numbers 2 and 4, the highest common factor of that is 2. But I can also take out a y as well. And then I'll open up brackets. What would I need here? 1 times by 2y gives me 2y squared. Well, that's y. And then what would I need here? That 1 times it by 2y would give me minus 4y. Well, that's minus 2. This is when we need to expand 2 brackets here. So everything in here must multiply by everything in here. Y times y is y squared. Y times 7 is 7y. Okay, now that's multiplied by everything over here. And now I need to move on to the 5. 5 times y is 5y. 5 times 7 is 35. Remember, that's multiplying all the time. A lot of people try to add those at the end. Then simplify. Well, I've got y squared, but the middle terms are both y, so I'm going to add those together. That's 12y, and then I've still got my 35 on the end. There's a slightly harder version here because it involves a negative as well. But just exactly the same, but you need to be careful with that negative. P times p squared. P times minus 8 is minus 8p. Okay, 7 times p is 7p. And then 7 times minus 8 is minus 56. So again, bringing those two middle terms together, minus 8p plus 7p, that takes me to minus 1p. Coordinates here, write down the coordinates of point P. Well, that's 1, 4. Write down the coordinates of the point B. That is 4, 0. On the grid, plot the point 3, 2 and label this point P. 3, 2, there we go. That is P. On the grid, plot the point minus 4, 3. Minus 4, 3. So it's there. Be careful not to put it down at this point here. A lot of people do that. That's the point Q. Now, it's a very tricky question here. Make P the subject of the formula. At the minute, M is the subject of the formula. So we need to reverse it so that P is the subject of the formula. So what I'm going to do is I'm going to concentrate on P, and I'm going to think about moving everything else across the other side in reverse. So I'm going to move away the 3n first, because that's the furthest away from the P. So I'm going to try and leave the P alone a little bit for a minute. So I'm going to have here M minus the 3n equals the 2P. Okay, so all I've done is move that 3n across the other side. It was positive over here, so when I move over, it will be negative. And then finally, I've got to get that p on its own, so I need to move the 2 over. Well, the 2 on this side at the minute is multiplying, so if I move it over, it will be dividing. So I've got here m minus 3n, all divided by 2 equals p. So you just treat it like an equation, really. So this is the topic of trial and improvement, and we've got our equation here. You will usually find this at the end of the calculator paper, and it's worth about 4 marks, so it's definitely worth getting right. I have added this table here myself, so I'll leave you a big space at the bottom to do that. And I've got a column here for x, and a column here for the expression, and then a column here for comments. So it's telling me that the equation here has a solution between 3 and 4. So I'm going to try 3.5 there. And if I was you, I'd get your calculator out now just to check that you get the same numbers as me. So I need to do 3.5 cubed plus 5 times 3.5. And with that, I will get 60.375. And I wanted it to be 67. So unfortunately, my number is too small. Okay, so again, I would check that you can get that on your calculator. So if that's too small, I'm going to try something a bit bigger. I'm going to try 3.7. Now, when I do 3.7 cubed plus 5 times 3.7, I get 69.153. And that, I wanted 67, so that is too big. So now, I'm going to try 3.6. When I try that on my calculator, 3.6 cubed plus 5 times 3.6, I get 64.656. Now again, that is too small. So I now know that my answer is either 3.7 or 3.6, because that's too small, that's too big. So what I'm going to do down here separately, I'm going to check the number in between those, which is 3.65. When I put that into my calculator, I get 66.877, and that is just too small. Now, if that's too small, that means that 3.6 is definitely too small, so 3.7 must be my answer there, my solution. Okay. Inequalities, this tells me that n is greater than or equal to minus 2. It can be minus 2 because I've got the extra line, or n is, and also n is smaller than 5. So write down all the possible values of n. So it can be minus 2, it can be -1, it can be 0, it can be 1, it can be 2, it can be 3, it can be 4, it cannot be 5 because it has to be less than 5. Solve this inequality. Well, what I'm going to do is I'm going to treat this inequality just like an equation, but I'm going to keep the sign the same the whole time. So if this was an equation, I would then move the 1 across the other side. It's adding on this side, so if I take it over, it will be taking away. So 11 take away the 1 is 10. And then I'm moving the 4 across. So the 4 was timesing on this side, and moving across it will be dividing. So 10 divided by 4 is 2.5. And again, notice I've kept the sign the same the whole way down. So that there is my answer. It's x is greater than 2.5. Inequality still here. On the number line below, show this inequality. So I need to draw circles above the -2 that I can see here and above the 3, and I'm joining them up like that. Okay, now it has to be greater than -2, it has to be less than 3, so these are empty. They're not coloured in, the circles. This one here, here's an inequality in x. Show this shown on the number line. Write down the inequality. Well, it's in x, and I can see that x is greater than -3, but it's less than 4. Now that one is coloured in, so it can be 4 as well. So x is less than or equal to 4. Indices now. And if you remember, when I'm multiplying, I add the powers. When I am dividing, I subtract the powers. When I have this bracket situation here, I am then multiplying the powers. Similar down here, I'm going to add the powers. And slightly tricky one here, I'm going to do this in 2 steps. So on the top here, 3 times 2 is 6. And then I've got q to the 4 times q to the 5. So that's q to the 9, because again, I add the powers. And that's still over q to the 3. Now I've got this dividing situation here, and then when I divide, of course, I have to subtract the power. So I've got here 6q to the power of 6. 9 take away 3 is 6. Straight line graphs here, or straight line equations. On the grid, draw the graph of x plus y equals 5. So they've left me plenty of space up here to draw a table. So that's what I'm going to do. And I can see down here on my x-axis goes from between -1 and 3. So I'm going to put those numbers up here: -1, 0, 1, 2, and 3. And what I'm going to do is generate the corresponding y coordinates. And I've chosen quite a strange one here, an unusual looking one. When x is 3, y has to be 2, because 3 plus 2 is 5. When x is 2, y has to be 3. When x is 1, y has to be 4. When x is 0, y has to be 5. When x is -1, y has to be 6. So here I've now got some coordinates, and I need to plot these down here. So first of all, I'm going to plot the point 3, 2. There we go. 2, 3. And then 1, 4. And then 0, 5. And then -1, 6. And notice they've appeared in a straight line together. If they didn't appear in a straight line, or I just have maybe the odd one coordinate out of place, then I'd come back up to the top here and check that my numbers were correct. The final thing I must do here is I must join these up with a ruler to get my final mark there. Okay, there we go. So you can watch this video again, pause, rewind, and ask your teacher for more explanation.